we all know that in a distributed system, data is kept at multiple places, right? The very primary reason for it is because this allows you to, essentially the first benefit is a single point of failure, right? That if the data is located at the same place, then it can, that node or can fail anytime, or the network which is attached to that node can fail anytime, and because of that, your system becomes unavailable, right? So to avoid single point of failure, replication is a helpful thing, right? Second important thing is replication also helps you to keep the data near to the user, right? So your application could be could be used globally across the world, and then this will allow you to keep the data near to the user. If the user is in India in a certain state, you can put the data in a data center which is in India. Similarly, if your user is in Australia, you can put the data in a data center which is co-located in Australia, and similarly so forth, right? So the network latency will be reduced. Very simple, straightforward things, just trying to go through that. Then scalability is, of course, the third major benefit, and essentially one of the primary benefits in that sense. What scalability means here is that because of replication, reads can be scaled very easily, right? You can redirect all your reads to the replicas instead of the primary or the master node, and then from the read you can pick up the data. That so essentially this allows you to scale the application horizontally, right? What happens to the right is a debatable, and I think a lot of the bullet points in this talk will touch upon that. But scalability again is a primary benefit which we get out of the replication. So these are the primary things. Anything you would like to add?
I think there is one more use case for why we need replication. So there are certain compliance related issues also, like for example, the data should be stored locally in certain geographical locations. Like for example, Europe has that policy, China has that policy, even India is enforcing that policy. So it's not a benefit, but that's a use case of why we might need replications of data in different geos.
Okay, but Karthik, that will require you to not keep the data outside the country also, right? So
Yeah, I mean, but you do need a distributed database, right? I mean,
uh,
in case your customers are in Europe, right? Then you
mm,
would need the data to be stored locally. So, I mean, it's a use case for creating multiple databases or like having a distributed database essentially.
Okay, so you
mm,
mean
Right.
if you have customers from different countries, so the
Right.
data related to that customer is should be stored in the respective countries.
uh.
Yes. If
But
there
I
are
mean,
regulations, yeah,
just
compliance
a little
regulations.
bit difference of opinion there. Maybe, of course, distributed database as you mentioned, but we might not need to keep one copy of data outside the country. That might not be allowed by data governance rules, right? GDPR.
Yeah, so
But
replication will not happen, but
no, replication will
partitioning it will
still
be, right?
be. Yeah, sorry, Ajit. Replication is still required, right? If you just keep a single copy, like for example, say in Europe, there are multiple like availability zones within AWS or Azure or whatever cloud platform you're using. So within Europe itself, you have multiple regions, right, or availability zones. So you can replicate in different regions within Europe continent. But I mean, if there is a compliance that you cannot keep the data um, like outside the country, it does not mean that you will not replicate it, right? You will need to replicate it. Otherwise, it will become a single point of failure.
But we might replicate in the same country, Karthik, right? Not at least from a legal
In the
standpoint,
same
I'm saying.
region, not
Yeah.
essentially same country. Yeah, in the same region.
Mm, mm. Yeah. So so the whole point of this chapter is that yes, replication will provide you these kind of benefits, right? But the I mean, this is very inherent to distributed system that it gives you a lot of flexibility, but because it gives you flexibility, there are a lot many things. It makes your system very complex, right? And because of that, there are a lot of things that you need to focus on. and do it correct. Otherwise, it will create a mess for you, right? So the next logical thing is, what are the challenges that replication itself will bring, right? So let's look at those. So now, very primary thing is just extending this thought is, now you have multiple copies of the data by definition. So if you have multiple copies of the data, it's your responsibility to make sure that it is fresh. It does not become stale. And so that is a major challenge, and there are workarounds to it. We'll go deep into it. Second thing is, the system in general becomes complex, right? You might have 1, 2, 3, 4 or more number of replicas, and so that means there are a lot more nodes to handle, right? So instead of one machine, now you have an entire cluster to handle, where replication could be there, other things could be multiple shards, again, in which the nodes will keep coming up and keep going down, I mean failing, and new nodes coming in, right? So how do you basically maintain uh, the copies of data, the same number of, so let's say you said I want to maintain a 1:3 replication. So how would you still, in a very complex live real time scenario where the nodes might go down and might come up, and how do you maintain still that 1:3 replication, right? That's a challenge. So in general, the system will become complex, and how do you maintain the freshness of the data on each of the replica, right? So these are the two challenges I feel which comes with replication. So I think what we have done is we have laid down the general idea of replication. What are the pros and cons of it, right? Now let's look at what are the industry wide. There are three kinds of replication which are supported by. I mean, there are, I don't know, hundreds, but there are at least tens of databases out there. Few of them we would all have got an opportunity to work on. So what are the three kinds which are supported in, might be in a few of these databases, right? So first of all is a very simple mode of replication, which is leader based, right? So leader based replication is okay. First breathwise, let's touch upon each of those. So first is your leader based. Second is your multi leader, where there could be one leader, more than one leader. Leader base is where only one leader is there. Third is your peer to peer, or otherwise leaderless. There is no leader involved, but uh, there would be all peer nodes talking to each other. So these are the three kinds of replication supported by all the database. So this is a very good view. We might not, I mean, this is individually, we might not go to each of the database, but if somebody tells us that, okay, this particular database, for example, Cassandra, supports peer to peer. So then we kind of visualize, okay, what kind of architecture would be there in Cassandra, right? Or if I say MySQL supports master slave, which is essentially leader based. So I can understand, okay, what kind of architecture MySQL have, right, at a high level, and talking about it. Similarly, we can configure Redis into a multi-leader. MySQL also can be configured into a multi-leader mode, I believe.
Yeah, I have seen like that in enterprises. The RDBMSs they use it in a multi-reader fashion. Generally called it active failover clusters, right? So that's where they use it, and the basic use case is you have um, what do you say, multi data centers. In each data center you have a leader, a master, to which you are writing, and your reads are basically okay. So your writes are always handled by your master in a particular data center that gets replicated to your uh, slaves. So I would say that's an example of the multi-leader. It generally comes in a use case where we have multi-data center scenarios. Although there are a lot of challenges with it, which we'll probably discuss.
Yeah, I think that is the most challenging replication mode. Yeah.
Like to add something on this.
Yeah.
It's just based on my memory. I am not 100% sure because SQL Server is, I mean, I have a very limited experience with the SQL Server. It supports multiple different type of application, which is not a part of this, but subtypes of what we have discussed. Like one is the snapshot replication, which is also supported by the data lakes. So it happens is like
Redis also supports
yeah.
snapshot.
Yeah, Redis also supports. And apart from this, there are different strategies, like whenever something pops up type of thing. Like one is that whenever something is published into the master, then only the slave updates it. This is one replication. Then there is a something updated onto the other side, and it has to be updated there. Something like we just discussed, master type of a replication. So that is called some update subscription or something like this, or maybe bidirectional replication. I don't remember the exact name. Then, like as we were discussing about something related to peer-to-peer, and if we see that sometimes peer-to-peer always have especially special use cases, sometimes which we have is transactional databases, not the consistent and eventual consistent type of databases. So most of the time that one database is directly like, okay, we will go into that as you will discuss about the sloppy quorum and hinted handoff. But yeah, these are the different type of a replication which my memory just clicked in, so I thought to share with the group.
Okay. I think yes. Maybe. Okay. So maybe this chapter does not capture this, and also didn't came up to mind, so I would have missed this. But yes, now snapshot I clearly remember as one kind of replication which Redis supports. Just to go little double clicking on that. So what Redis do is Redis, for example, is just primarily an in-memory store, right? Primarily I'm saying is in memory state, but also for durability reasons, it says that, okay, you can copy the data to the disk, and it supports two mode. One is snapshot. So basically, at a certain interval of times, right, periodically, it will just take the snapshot of the memory and then put it into the disk, right? So Redis, for example, if you have configured a 4 GB or let's say 16 GB memory you have, right, then you can have a disk also of 16 GB size, and it will just take the data from the memory and snapshot it to the disk. So exactly same copy you have. So just in case if your node goes down, it can build the entire memory from the disk. So that is your snapshot mode of replication. And other one which Redis support is append only. So it can, if you configure Redis into an append only format, it can just take the data from the memory and just keep writing in an append only format to a file on the disk. So I think these could be little bit, but I don't know, maybe it's not very standard way or something. So that's the reason it's not covered as a top level item.
Okay.
Yeah, that is
Sorry.
true. That is true. Sometimes it is also configurable to the end user by some of the databases. Like if a customer wants to use the snapshot application, they can do it. Otherwise, the by default mode could be the append only, or maybe something like this is supported. This is just my hunch.
Sure.
Yeah,
Brijesh?
I have just one point to say that. Okay, so this snapshot is a mechanism that we say it generally doesn't fall into the category of the replication that probably we are trying to classify upon, or the book try to classify upon. Like it says single master or master slave, then multi-master and peer to peer. So snapshot also comes into the picture, like Kunal rightly pointed out, that when you try to add replicas into master slave ecosystem, right? Let's you're trying to add a fresh new node into the replica set. So snapshot comes into the picture, that you take the snapshot from the master, the entire data that you get in a snapshot, you know like put it on the new node, and then from the point you took the snapshot from the master, you replicate the data to the new node that you added. So I would say snapshot itself may not be considered as a replication mechanism, but yeah, this is a mechanism to like which can help you in the various uh, actions that you can perform upon.
Okay. Okay.
We can start with
true. Yeah.
with start with master slave, and then we can like proceed with multi-master and then peer-to-peer, discussing about the challenges in
Yeah,
each
I
of
think
these.
we're still touching upon the basics. When we go, let's go to the little bit deeper concepts. So, okay, I'm just trying to catch up till where I've covered. Client directly does not make write on the follower node. Yeah, yeah. So essentially, one difference between leader and follower is that the follower replica will not be updated, right? So read can happen from leader as well as on follower, but write will not happen on the follower replica. So, or replica generally is loosely also used for a follower in that sense. When somebody says replica, he might mean a follower or a slave instead of a leader. So, and so sometimes follower one is you can use it for reading, and also for backup and disaster recovery followers are used. And so typically follower can be at a very can be in the same data center also, and it can be geographically located very far away from the main data center, and in that case it's used for a DR activity. So if, let's say, because of some kind of natural disaster, the data center itself is cut off, so you still have a backup copy of the data located somewhere else, so which you can use and you will not lose the data. So I mean, you might lose little bit, depends on what kind of replication you have used, which is synchronous or asynchronous replication, but that guarantees that most of the data is present. Okay, now let's come to, I mean, I already touched upon, so these two kinds of replication. One is the synchronous replication, another is asynchronous replication. What synchronous replication means is that from the leader and to the replica, the data will be copied while the user has not received a success response, right? So user is writing, he has not received a success response, and in the same call itself, you are waiting for the data to be replicated to the follower. And once the follower also acknowledges that, okay, I have stored this data, and then the success return to the user in a synchronous replication. In asynchronous replication, this particular activity of copying the data onto the slave, that will happen on a background thread, on a background process. So essentially, it would be so I think
The
this is the
right,
primary difference. Yeah, yeah,
then
Ajay.
the right will be a bit slower because of the
Yeah.
synchronous nature of this, right? Hmm.
Yes. Yeah. So I think, yeah, you already said one is, of course, if you are using synchronous, then you will have a higher latency because now you have multiple nodes where it might be written and then only you will give a success response. So latency spikes up. But the advantage is that you will
Consistency
not,
you get.
you might not lose data, right? So let's say your leader goes down, right? And in that case, if the follower, because follower is copying the data asynchronously, then follower might lag by few records to few thousand records, right? Somewhere in between, it might lag. So from that point of view, it can happen that if the leader goes down, you might the follower might not have catched up, and then you lose some amount of data. So if you are using synchronous replication, that will not happen. But of course, latency will be higher in case of asynchronous replication, and no data loss will happen. Okay, now let's go to what are the ways in which replication is done, right? In
Hmm.
in in various data stores, right? So I think,
Yeah.
yeah, Brijesh.
Okay. Just a point. Can we kind of give any example where synchronous
Hmm.
way of replication being used? Has anybody seen that? And could be a.
Hmm.
I think one thing probably we can say is that is the way we do the write through cache update. Obviously, that's probably not could be a replication example, but uh, it's like when you update the cache and simultaneously you update your source values also, right?
Yeah. I think that's is a fairly close example. Yeah, because cache
Other than that,
ultimately is again a data store. Yeah.
yeah. So having said that, there are so many downsides of it. Maybe people don't use it, right? The synchronous way of replicating.
Ranking could be one area where it might be used
Hmm.
because
No, I'm in case of distributed systems probably, because on single, in case of single node way of doing transaction acid ways, probably could not be a, you know, relevant example because that's
mm,
already single machine. So, but in case of like distributed machines, is there
I
is
think
there an
what is the
example?
standard practice, or what is the standard database, right? Which uses, if anybody knows an example for that.
nope,
Okay,
nothing
let's
from my
proceed.
hand.
Maybe, yeah.
Yeah, I just thought about it, but I don't. I was also not able to collect. I think HBase is also async replication, and similarly is for the Aerospike also. So yeah, most of the databases are distributed databases are following the asynchronous one.
So I think primarily because all these databases, most of these databases target availability, availability. And if you follow synchronous replication, so just want to touch upon this. If you have, let's say, 1:3 replica, there are 3 nodes. And then even if you're saying synchronous, that means the data on one node has to be copied to 2 other nodes before you can call out a success. And that means even if one replica goes down, then you'll have to stop accepting writes, right? Your entire cluster goes down for writes. Write is not acceptable. It becomes a read-only cluster. So that's the reason it's generally not preferred, not used. Okay, but there could be one example. Let's say when you have a multi data center setup, right? I think Shivam, this thing was there in Flipkart when we migrated our data center from Mumbai to Chennai, and we were still maintaining the Mumbai data center also, right? So Chennai, we used to write on the Chennai data center, but then it used to get replicated in Mumbai as well, and that this was, I think, done in a sync way. So what happens is, let's say, yeah, what happens is your Chennai data centers goes down because of something. And I do remember a scenario where uh, in the, I think in the flood of 2015, which was a very disastrous flood for Chennai. This actually, the flood water entered the Chennai data center of Flipkart. And so, I mean, this could be a hearsay, but what I heard is that people have to take out water from the data center by using buckets and throwing the water out. So that kind of scenario has happened. And so, just generally speaking, in all those kind of scenarios, since you have a sync replication, then all you will not lose data, and your data is replicated at the other data center, which is located at a far away. So even if your entire Chennai data center would have gone down, Flipkart would have still operated, at least those services which uses this would have been unaffected, right? From a user's perspective.
I think
Yeah,
this
Karthik.
this seems like a example of the active setup, right? The multi-master.
Yeah. So I think synchronous is an active, but again, the thing could be that whether those are also used for all your OLTP transactions, or those are essentially only for backup, right? That could be a difference.
Yeah.
So
Karthik.
I actually had a question. So
Yeah.
is like, do most databases only support asynchronous, or is there a property or a flag which we can use to switch between synchronous and asynchronous? Or are there any dedicated databases which we need to use synchronous? Like, for example, you are saying right now, so
Mhm.
say in my like during my design phase, I chose a technology, say some MongoDB maybe, and that writes asynchronously, but tomorrow I want to change it to synchronous. Can I do that?
So in my opinion,
Yeah,
the answer is yes. This is a configurable thing. This should not be a responsibility for application developers to do it in an application code, uh, which the book also is trying to claim it, that these are the responsibility which you should not be giving to the application development thing. And a database software should be uh, like responsible for doing this. So I think in MySQL I have seen this, that there is a configuration where you can set it as to be a synchronous versus asynchronous, and I hope other databases also have this configuration which can be done.
Okay.
Yeah, I think if somebody knows deep about Redis, they can talk about it. Redis also has this right, master slave is there, then Sentinel based clustering you can do, and I think peer to peer also you can set up. So Karthik, yes, I think generally answer is yes. Database, but of course it will depend on whether that database has inherent support for it. For example, as Vijay said, MySQL supports it, but you'll have to go up by the data store. Some of the data store might not be supported. Then, so some of the databases might have defaults that okay, the default is asynchronous, and some of the database might have a default as synchronous, but and some of the database might support just one of those. Other would be in
Sure.
a disabled format. Yeah.
Yeah. Got it.
Okay.
This
So
actually little bit goes into our previous discussion about the data models, and like it was also said that your database systems are generally made to be declarative than imperative, so that you could just be worried about what you want and not about how the things are happening under the hood. So I mean, yeah.
that is with respect to the queries, right? Declarative and imperative.
And yeah, so that
Your
also
query language, right?
applies to replication also.
Okay.
Yeah.
Okay. I think you're okay. You're saying the same concept. You just change in the config. You don't worry about how it happens in the background. It will
Yeah.
happen. So coming to the how could the replication be implemented, right? So very simple thing could be that the slave basically connects to the leader, and then it asks for okay, what are the right requests that it has received, and then it can copy or the same right request and apply them on the slave, right? And in that way, the slave will have exactly the same set of changes if applied on the slave also. It will have the it will have the consistent data with respect to the leader, right? That is a very general approach. There are, I think, detailed way, there are 2-3 ways which have been suggested. For example, I think one famous being MySQL uses bin logs. So the slave, instead of copying the query exactly, what it will do is it will try to read the bin logs, and from the bin logs it will see okay, what are the changes that has been applied, and then slave will apply the changes on its data. And similarly, whether it's an insert query or update query, you will have again the same data which is there in the leader. So that's how it happens. One problem though with this approach is some of the things are pretty much deterministic in the nature, right? So one example which I have written is, let's say you want to update a date column with a now record, right? Now, when this statement would be executed on the master, it will, at the time of execution, whatever is the timestamp at that point of time, it will write that timestamp. But if slave just copies the now statement and executes on itself, then the slave will have a now of that point of time. It might lag by few minutes, few seconds, or few hours also. So then slave has a different set of data with respect to the master. So this is one problem with this kind of copying exactly those statements onto the slave, and it's not a right idea then. So generally in those cases, either there would be some kind of way to remove those deterministic statements, and change those deterministic statement by some kind of local manipulations there, and change it with the data from the leader, and then apply those changes. Yeah, guys. Rajesh, I think you can talk
Yeah,
about
so
this. Yeah.
yeah, I think so. So basically, if you go to the fundamentals,
Hmm.
uh, even in RDBMS, we maintain a log file. So so I don't know if it is in MySQL, but in MS SQL we do have data files and log files. So in log files, we always, like, let's say we are trying to perform a transaction, whether it is insert, update, delete, or even select. I don't know if you can select, but yeah, in case of DML, so we write everything in the log file, like what exactly are the operations that we are trying to perform. And I guess this append only thing that is like quite popular in NoSQL world is had been kind of inherited from that, because even in RDBMS case, that log file is always append only. So and that's where your transactions commit and rollback get supported. So when we say like we are able to roll back, so what we do is every, like, let's say you have a transaction running and you have multiple DML statements in that, so you write everything in that log in an append only fashion. If your transaction gets rolled back, you just like kind of remove it, or I don't know what it how it is done, but let's say remove it from that log file, and you gets your data gets rolled back or your transaction gets rolled back. So what I what the point I was trying to make is that when you try to replicate is this uh, log replication is something which generally happens. I don't know, we call it log shipping or something, or maybe log shipping is something different. So uh, this is like what happens. I see you have mentioned change data capture. So change data capture, uh, as in case of MS SQL, is actually what it does is like when you kind of enable the change data capture on a particular table, uh, whatever operation you do, update or insert or delete, that separately gets recorded in a CDC table. So change data capture, in short form, is CDC. So let's say you enable you have a table person and you enable CDC on person table, you get a person underscore CDC table separately gets created, and for any of your DML operation, you push an entry to that CDC table where you have record of what was the previous value and what is the value after your operation. So you record basically both thing there. So that's actually have like is the enough information for you to send it to somewhere else and kind of apply those operations in the order that it was performed on master, and then your slave data is also in sync with master. So I guess that's the way probably this is being implemented, the replication logs.
Kunal, I have a point. So
Yeah.
say you were talking about now method, right?
Yeah.
What if in the logs we don't write now, we actually convert it to whatever the timestamp is being stored and then use that timestamp. So whatever methods we are trying to use, right? What
Hmm.
if while writing to the master itself, we calculate the value and then translate it into an absolute value which will be inserted and then write it to the logs? Do you think?
Uh,
Uh,
yeah, Karthik, I think that is correct. So that's what is some of the remedies which you can apply to
exactly.
prevent that problem. Yeah, I think so. In fact, timestamp in case of now, and then there could be some functions also, right? I think Brijesh
Correct.
again knows more about it. Some kind of functions which you apply on the records, right? Those functions could also be deterministic. So those
Correct.
also the derived value should be applied instead of those functions. So I think
Exactly.
yeah, that's how. Yeah.
So that
Right point.
then when the slave reads that log file, or I mean a follower reads that log file, it would have an absolute value and the data would be consistent across replicas also.
Correct. Agreed.
Yeah, so this is actually the value update only. So what value was changed and what is the current value, yeah, of that field. Yeah, I think we call it row based replication, right, Kunal?
Right.
Yeah, it's
Rather
called
than
row based.
stable
Yes.
based.